So which of these kinds of bombs could a terrorist group build? Well, how about fission bombs? Well, not easy, but yeah, they could do it. But it's going to be awkwardly sized. It's not going to be sleek, compact, easy to transport or use if it's built by a terrorist group. It's doable, but not easily done. Therefore, it'll be a kind of a bulky device. The really hard part is to get the fissionable material, and we'll talk about that in a second, why it's so hard to get the fuel for a fission bomb. Fusion bomb, no way. For the reasons I just said, you have to have a fission bomb to trigger a fusion bomb. There's no point for a terrorist group to make a fusion bomb if they can make fission bombs. So that's just no way. Dirty bombs, easy as pie. Any bad person can make a dirty bomb. Okay, so let's go one by one through these and talk about why they're difficult to make. A fission bomb. Why is it so hard? Well, as I said before, there are two kinds of fission bombs. One based on the fuel uranium-235, the other based on the fuel of plutonium-239. Now, uranium-235, that kind of bomb is really easy to build. You can go online, the bad guys already know this, you can go online, you can find step-by-step instructions on how to build this uranium-235 bomb. And it's a potent bomb. But it's really hard to fabricate the fuel. And I'll talk about why in a second, but it's really, really difficult. It's highly unlikely that a terrorist group could assemble the resources necessary to make the fuel for a 235 bomb. Plutonium-239, it's easier to get the fuel, not easy to make it, but maybe you could steal it from someplace. So it might be a little easier to get the plutonium-239 fuel because it turns out that the plutonium bombs, those are sort of the fuels of choice for countries that have nuclear weapons. In the US, we pretty much don't use uranium bombs, we use plutonium bombs because we can manufacture the plutonium in reactors and have lots of it. And so if some of this 239 were lying around someplace and were not properly guarded, it's, I guess, technically possible that the bad guys could steal the 239. Now, if they were able to get their hands on plutonium-239, it's really, really, really hard to make a properly operating bomb from 239. And we'll talk about why that is in a second. So here's the point. Uranium-235, easy to build the bomb, but hard to get the fuel. Plutonium-239, easier to get the fuel, but really hard to make the device. Okay, so the take-home message from all of this is uranium-235, they're really easy to build, but really hard to get the fuel. For plutonium-239, it's easier to get the fuel, but really, really hard to build a working bomb. So that's sort of the take-home message, the short message from this in terms of terrorists building fission bombs. Now we'll supply details later in the course on exactly how all this works, but the short message on uranium is, first you have to mine the uranium. It exists naturally in the ground. It's in many places in the US. It happens to be a lot of it in Iran, for example. There's a lot of it in North Korea, just lying in the ground. It's all over the world. Lots and lots of uranium ore. So it's not that difficult for a bad guy to get their hands on uranium ore. Even terrorist groups can get their hands on uranium ore. However, even after you have the uranium ore, you have to purify the uranium. And that's not as easy. It's some really nasty chemistry, involves really strong acids, and all of this stuff is radioactive. So it's not trivial to do this. And you need a lot of ore, to purified ore, in order to make enough fuel. This is the really hard part. You have to enrich the uranium. By enriching the uranium, more details later, but by enriching the uranium, as I said before, most of the uranium in the ground is uranium-238, and you have to have some method of getting rid of the 238, which is useless for a weapon, and leaving behind the uranium-235. And there's not very much 235 naturally lying around. And so this is the really hard part. It's really expensive. It's an enormous operation, costs billions of dollars to set up a facility like this. So here we could talk about rogue nations doing this, but not so easy for a terrorist group to do this. Now in the case of plutonium, you either have to steal the plutonium or you need a very special reactor to make it. As I said before, in a conventional reactor, you naturally turn uranium-238 into plutonium. But fortunately, most of that plutonium is the wrong kind of plutonium. And in fact, that wrong kind of plutonium not only doesn't undergo fission very well, but in fact, it prevents the efficient use of the 239 in a bomb. So you can't just grab the uranium that's left over from a power reactor. You really need to have a special reactor that makes this 239. Plutonium does not exist in nature at all, so no mining operation is going to help you out here. And because of that, you're always going to have some of that plutonium-240 mixed in with your 239. That 240 pre-triggers the bomb. And so the bomb never really explodes all at once. Remember last time we were talking about the difference between energy and power. What happens because of the 239 that's mixed in with the 240 that's mixed in with the 239 is that it sort of pre-triggers, and so the energy sort of trickles out. It kind of blows the bomb apart, and so most of the fuel isn't available to undergo fission and release a huge amount of energy. And in order to get it to work properly, you have to use very sophisticated timing so that you detonate all parts of the bomb at the same time and squeeze it in. And that's really hard to do, and it takes very special electronics to do it that is not very easily available. Otherwise, you get what they call a fizzle. By fizzle, we mean an explosion that is more along the lines of a conventional weapon explosion instead of a nuclear explosion. So what about dirty bombs? Can terrorists make dirty bombs? The answer is, yeah. They're really, really easy to build. All you do is take a conventional explosives, like the explosives that were used in the Boston Marathon bombing, for example, and then throw in some waste from nuclear medicine facilities, or even smoke detectors. I mean, I could go to a hardware store all around, buy lots and lots of smoke detectors. Smoke detectors all contain nuclear materials. That's how they work. Now, the nuclear materials are contained. You don't have to worry about being contaminated from your smoke detector. However, a bad guy can open up the little capsule inside the smoke detector that contains the fissionable material, not fissionable, the radioactive material, cesium-137, and mix it in with the explosives. Then when the explosion occurs, this fissionable material, this radioactive material is dispersed and people can get radiation sickness. Okay, so it's really, really easy to do. But the good news is it's not really that destructive. Most of the damage is done from the explosion, not from the radioactivity. And there's a good physics reason for this. If you want to injure lots and lots of people with the radiation, you need to have a big explosion so you can disperse the radioactive material over as large an area as possible. But the more area you cover, the more dilute the radiation is. And the harmful effects of radiation, as we'll see later in this course, are proportional to the amount of radiation you're exposed to. So if you really disperse it over a large area, then the activity in any given part in that area will be significantly reduced. And it'll be reduced like the square of the distance away from the bomb. Now what you could do is you could have less dispersion. That way you'll have a larger dose. But if you have less dispersion, it's a smaller area that you're affecting and you'll hurt less people. So the good news is that with these radioactive isotopes, causing radiation damage to people, there's an effect that sort of cancels out. The bigger the area, the more people, but the bigger the area, the weaker the dose, therefore you affect less people. Now, what you could do, of course, is to put more radioactive material in there. The more radioactive material you put in, now when you disperse it, the dose everywhere will be higher because you put more stuff in to start with. But there's a limit to how much you can put in, because the terrorist, even if he's a suicide guy, he doesn't want to die before he can assemble, place, and detonate the device. So if we're talking extremely potent stuff, well, the terrorist will be exposed to this really potent stuff and will die before he or she can assemble the bomb and bring it to where he or she plans to detonate it. So there are natural limits to how much radioactive material the terrorist can place in the bomb. So that's a good thing. Basically, what it boils down to is the biggest threat is panic. There was panic at the Boston Marathon bombing. Not as much as one might expect, because people really were pretty level-headed, but there was still panic. Imagine if word had gotten out, it wasn't the case, but if it had been the case, and word had gotten out that that explosion at the Boston Marathon was dispersing radioactive materials. People would absolutely freak out. Okay? I mean, especially if you don't understand radiation and what it can do to you, you just know it's bad, but it's an unseen bad, people would just freak out. So the biggest threat actually from a dirty bomb is panic. But that's a pretty serious threat. So, you know, this is something we should watch out for. I think it's the case when bad guys purchase huge numbers of smoke detectors, some alarm signal goes off and FBI or Department of Homeland Defense, I think these guys are alerted, but I'm not sure. So what about stolen nukes? We said that it's difficult to manufacture the material in the case of the uranium-235 device, and we said that it's really difficult to make the weapon in the case of the plutonium-239 device. Why can't the bad guys, the terrorists, just simply steal a bomb? Well, certainly it's possible. But typically these things are really well guarded. Now, on the other hand, there are a lot of weapons that are not accounted for. It could be sloppy bookkeeping, but there could be some weapons sitting around in, I don't know, Kazakhstan, and maybe there is somebody guarding it who maybe isn't all that trustworthy and is willing to sell this bomb if he could then get enough money that he could buy some island in the Pacific someplace and live happily ever after. So this is, you know, even well guarded, something we need to worry about. On the other hand, all of these weapons that were made by the former Soviet Union and Russia now, and the US and in China, all of these weapons have been booby-trapped. They're not that easy to screw around with. They're not that easy to detonate for just an uninformed person. And typically the people guarding the bombs don't know how to set them off. All right, they're there to prevent other people from taking the bombs. They're not there to teach somebody how to explode the bomb. So this booby trapping means that they're not that easy. Even if you do manage to steal a weapon, it's not that easy to use the weapon. On the other hand, that still is currently our greatest threat in terms of a nuclear device in the hands of a terrorist. Is stealing it. It's so hard to make one, given the fuel situation, etc., that still the greatest threat is that the terrorist group steals one. That is, until a rogue nation develops nukes and then can supply that nuke to a terrorist group. One of the reasons why there's so much negotiating going on currently with Iran is not so much a fear that Iran will launch a nuclear attack on one of its neighbors, but that Iran might, if they were to develop a weapon, if they were so inclined, that they might hand a weapon to a terrorist group who could then use it to attack, for example, Israel. This is what Israel's main concern is. they're not overly concerned that Iran will create a weapon and launch that weapon at Israel because the world would retaliate, most likely. What they are worried about is that Iran, if they develop the nuclear weapon, might give or sell the weapon to a terrorist group who could then use it to attack whomever they want. On the other hand, any nuke has a characteristic signature. If the U.S. were to explode, we're not allowed to do this, we signed a test ban treaty, but if that test ban treaty were to expire and the U.S. were to explode a nuclear device, even a fission device, it would have a characteristic signature in terms of the radioactive isotopes that it would produce. And that signature would be different than a nuclear device, a fission device exploded by Russia, or one exploded by China, or one exploded by North Korea, or any of the other nuclear nations. Okay? They're all just a little bit different, and they'll produce a slightly different ratios of nuclear materials. Therefore, if a rogue nation were to develop a nuclear weapon and they were to give it or sell it to a terrorist group, they would not really have plausible deniability. Everybody would know where this device came from. And therefore, that rogue nation could be subjected to retaliation from the other nuclear powers. So even though that still is our greatest threat, until after a rogue nation develops a nuke, that would then become our greatest threat, still one would have to try to, it's a difficult job, but one would have to try to assess how likely this is, simply because of accountability from that rogue nation. Any questions? We're talking about anything having to do with nuclear weapons in the hands of terrorists.